Chapter 2, Exercise 27. Given examples of sets A and B for which A intersect B is non-empty and the intersection of A intersected with the intersection of B is not equal to the intersection of A intersect B. Okay, lots of intersections. And I'm going to be real with you. I just played around with a bunch of different sets until I found an answer. I usually keep my sets small, but I'll just give you my answer and hopefully you can come up with your answer on your own. Shouldn't take too long. It took me about 10 minutes, I think, if that. So, anyway. Right, so I'm just going to say that A is equal to the set containing the sets 1, 2, and 1, 3. And B is going to be equal to the set containing the set 1, 3. Okay, immediately off the bat, we can see that A and B have an element in common, so A intersect B is non-empty and is in fact equal to the set containing 1 and 3. And now let's construct the different other sets. So just make that abundantly clear. Right. Let's see. Oh yeah, intersect A is going to be the set of elements that appear in every element of A. So let's go through each element that appears in an element of A, one by one, and determine whether it deserves to be in the intersection of A. So 1 appears in this element, and it also appears in this element, so it surely should go in the intersection of A. Whereas 2 appears in this element, but does not appear in this element. And the same goes for 3, which appears in this element, but is not in this element. So turns out that the intersection of A is just 1. Now let's see the intersection of B. Let's see, 1 appears in this element, which is the only element of B. So, kind of trivially, it appears in all elements of B. Similarly, 3 appears in this element, which is the only element in B. So, there we go. Okay. So, what does this mean? This means that the intersection of A intersected with the intersection of B is going to be equal to the set of elements that appear in both. So there's 1 here, there's 1 here. Oh my god. These get progressively more horrible as time goes on. Okay, so 1 is here, has its spot, and then 3 is only in this intersection of B, but it's not in here. So this is all this set is, whereas the intersection of A intersect B is going to be the set of elements that appear in every element of A intersect B, which is going to be equal to 1, since it appears in this element, and that appears in all. 1 appears in this element, and thus it appears in the only element of A intersect B, and thus appears in every element of A intersect B. Same goes for 3, appears in this element, so it appears in every single element of A intersect B. So we get 1 and 3. And look at that. So 1, the set containing 1 is not the same as the set containing 1 and 3. So intersect A, intersect B is not equal to intersect A, intersect B. As requested. There you go. Are you happy now, Enderton? Right, hope this was helpful, and I will see you in the next video. Bye bye.